Hey students, remember when we had that conversation about we were walking through a quadrilateral forest, or really the land of polygons. We got to the quadrilateral forest and we were looking at the soils and we thought, okay, well, what kind of quadrilateral will this soil produce if this soil will only produce quadrilaterals with 4 equal sides? And we said that kind of soil would only produce rhombuses and squares, because those are the only kind of quadrilaterals that have only 4 equal sides. So that's what this lesson is about. This lesson is about the kind of soil that produces parallelograms. Just like the kind of soil in this forest produces rhododendrons. As I can see, I've got a rhododendron here. This kind of soil, slightly acidic Western North Carolina soil, is great for producing rhododendrons if we have the right climate. So just like we're trying to figure out what kind of soil produces different kind of plants, we can do the same thing again with quadrilaterals. So just as an exercise, think in your head, what kind of quadrilateral will grow if I only have soil that produces quadrilaterals with all right angles? So you should think right away, you should think, I know that. That's going to be a rectangle, and all squares are rectangles, so of course it makes sense. That's going to be a rectangle. You might say to yourself, Mr. Hale, I already know the sufficient conditions for a parallelogram. And I'd say, hey, you already know one of them. What's one of them? Well, straight from the definition of parallelogram, we know that a parallelogram is a quadrilateral with 2 pairs of parallel sides. That's all you need to know. So you're an agricultural prospector. This is what you look like. And you're hiking around and you're looking for soil that can grow pawpaws. Pawpaw is a native fruit to North America. It's kind of like a pear that tastes custardish. It looks kind of like a banana, a pear, or a mango kind of mixed up into one. I'll show you a picture. So you're marching around and you're looking for soil that can grow pawpaw trees. And, well, where would you look for soil that can grow pawpaw trees? Well, you might want to try and find a patch of pawpaws and then look at the soil. So you hike and you go up a river and you see, well, here we go. Here's a pawpaw tree. Let's draw some pawpaws on this tree. So this is a pawpaw tree, and that's a pawpaw tree. And you hike around and you say, okay, well, this is a hickory and an oak, and I'm hiking along this river, and there's a pawpaw tree. Hiking around the river, there's a pawpaw tree. Then I go and I hike up the mountains, and I am not seeing any more pawpaw trees. So I come to some sort of realization that pawpaw trees require well-drained, fertile bottomland, and they often grow near oaks and hickories. So if we think about a geometry forest and we are in the land of quadrilaterals, we're trying to think about the soil that would support growing parallelogram trees. What kind of conditions, what kind of nutrients are necessary to grow a parallelogram? That's what this whole lesson is about. So I'll outline, there's 4 of them. Oh, the first part that I forgot to tell you is, well, we look for conditions that are similar to where actual pawpaw trees are growing. So if I see, well, there's actual pawpaw trees in this area of land here, then I might look for similar land and try and plant more pawpaw trees right there. So what are the conditions that we know already for parallelograms? We already know one of them. So one of the conditions you already know is that a parallelogram is a quadrilateral with 2 pairs of parallel sides. And that's the first one, and there are 4 more, and we'll go over those right now. So the sufficient conditions for parallelograms, the 4 of them we're going to describe today, can also be called the sufficient conditions for a parallelogram theorem. Sufficient. What does the word sufficient mean? That means like it's enough. It is enough to qualify something for something else. So if you've taken the sufficient prerequisites for geometry, you can be in geometry. So the sufficient conditions for a parallelogram. Parallel. Gotta sound it out every time. This is the sufficient conditions for parallelogram theorem. So we started out and we say if in a quadrilateral, this qualifies our wanderings to only exist within the land of quadrilaterals. If, oh, I wrote if twice. If a quadrilateral, if in a quadrilateral, I need to edit that. If in a quadrilateral the following things are true, then I have a parallelogram. If in a quadrilateral, comma, A, this is the first one. One pair of sides is both parallel and congruent. So this is our parallelogram. We know it's a parallelogram because of the first condition of our sufficient conditions for parallelogram theorem, which says one pair of sides is both parallel and congruent. This is kind of like our triangle congruence theorems where we don't need all the information, we just need a little bit. If I know these things, that one pair of sides is both parallel and congruent, then I know that this parallelogram is, that this quadrilateral is indeed a parallelogram. Okay, the second one is that both pairs of opposite sides are congruent. And we were to draw a picture of our parallelogram. It would look like that. Both pairs of opposite sides are congruent. That guarantees that this quadrilateral is a parallelogram. Point C, the diagonals bisect each other. This might remind you of the rhombus diagonal theorem, which says nearly this. And it is true that rhombuses are parallelograms. So we draw our diagonals. And we see that this distance from here to here and this distance from here to here are the same. That's what it means to be bisected. And the same could be said for that diagonal. That condition is sufficient to know that this quadrilateral is a parallelogram. And D, our last point, is that both pairs of opposite angles are congruent. And you could draw a picture. If this is a parallelogram, these opposite angles are going to be congruent, and these opposite angles are going to be congruent. Have a great day.